Hi guys, welcome back. So this is the second video of how to use the JMOAB with the ROS2. If you haven't watched the first one, please check on the link above. So for today, I'm going to show you how to use the JMOAB to control the ATCart by using the ROS2 topic. So what is the ATCart? Some of you may have seen my previous videos about the ATCart. Simply speaking, the ATCart is the wheelchair motors which has the this ESC. So it's a brushless wheel hub motor which is really powerful. You can like sit on it and drive around. It uses the serial communication to send the power to spin the wheel. So at this moment we cannot have the output feedback from the ESC, so we can just estimate like how much RPM is going to spin. So the max RPM of this motor is around 145 RPM, which is quite fast for most of the robot application. And for about the ESC, the JMOAB 06 is only support for this model number. So it's the MN1 WSDC/3 7F and G-X. So only this model that the JMOAB 6 can support. And we also have designed the aluminum bracket that can hold the wheel hub shaft and attach on the 30 by 30 millimeter aluminum frame. So you can just order this aluminum frame from Mitsumi or anywhere, and then you can make up your own cart. And this is what we're going to put on our ATCart. So first thing first, this is the main battery, a 6-cell LiPo battery. So it's going to connect to this connector, and the 24 volts will go to this DC-DC converter, and the output 5 volt here will supply to the Jetson Nano and also the Wi-Fi router. So this Jetson Nano is what we have done on the first video. It's already set up the JMOAB ROS2. And we're going to use the Wi-Fi router because we're going to SSH into the Jetson wirelessly and control from our laptop. And the ATCart ESC communication cable is plugging on the ESC 1 port here. Power to the ESC is by this red connector. So we have the S-Bus RC receiver, so we can control the cart by manual or auto by sending command velocity to it. So that is what I'm going to put inside the car. Okay, so I put everything inside the box now, and the battery is outside and also the ESC is outside. So here is the only plug that I need to plug on. Then everything inside will get power, and then we can control the robot immediately. So I'm going to plug it now, and I hope nothing won't get blown up or get fire. So that would be a real big problem. Okay, then let's try to plug on the battery. Okay, no fire, no smoke. That is a good sign. Then the Jetson Nano got power. Everything got power. So here is my transmitter. So if I switch here the channel 5 to the middle, then I can control the robot right away by manually. So the throttle is this one. And then going back, so it's a proportional control. So how much you push the stick is how fast it's gonna go. And this is the steering. Okay, so it looks fine. So we can close the control box lid. Okay, so the manual control on the robot is taken care of by the JMOAB. So once it got power, you can control the robot immediately by the transmitter. And you can also stop the robot by putting it on the hold position. Then even you push the throttle or steering, is not going to move. But of course, if you put it on the manual, then you can control the robot again. And I think that is a good function for the robot to have, because you want to take control to the robot immediately if there is something happen or something goes wrong, so you can take control all the time. So we have confirmed that everything is okay. Then we're going to move to the ROS2 again. Okay guys, here is the fun part. So back to the laptop. Now we're going to send the ROS topic command to the robot to let the wheel spin. First, we need to connect to the robot Wi-Fi, because I told you that there is a Wi-Fi router in there. We need to access the robot Wi-Fi by, it's this one, 20C 2G. Okay, then we need to go to the admin page first for the Wi-Fi router, because we want to know what is the robot IP. Then put the admin password, no thanks, and then check on here the LAN clients. So this is the robot IP, is 244. So I just open one terminal first, and then SSH with a Jetson at the robot IP. So the password is Jetson. Okay, next we need to run the ROS2 run JMOAB ROS2 and with the node ATCart basic tab. Okay, then let's start this and hope everything will be fine. Yep, and it's fine. Okay, so let me show you another Windows here. So here I put the webcam behind the robot, and I lift it up with some plastic box so the wheel is not touching on the ground. So this is just for safety first, that we want to make sure we can control the robot by the ROS topic. So I'm going to use the transmitter again to show you that now it's spinning in the air, nothing touched on the ground. Okay, I need to open another terminal. So as you can see here, this ATCart basic node is subscribing on the command velocity. So which is the standard command velocity that you might get used to it when you develop the ROS program before. Or if you haven't, if you don't know about this, it's okay. The command velocity is just the command of the velocity in linear and the command velocity of the angular. So we can, it's like the throttle and the steering on my transmitter. So here is my terminal on my laptop. But first I need to source the ROS environment. Okay, and if I do ROS2 topic list, so you will see that there is a ROS topic appears on my laptop. So I can do something like this: ROS2 run RQT robot steering, RQT robot steering. Okay, so there will be a GUI that you can send the linear or the angular velocities to the robot. So now I will switch the robot to the auto mode, which is the channel 5 and on the coming on your side. So if I put it here, this is the auto mode. You can notice that the ATCart basic node is showing some log data of the command velocity and some of the left wheel S bus, right wheel S bus. Okay, we don't need to know it now. But anyway, here on our laptop, we can send the command velocity by, for example, slide this up. And wow, you can see that the wheels start to spin once we set the command velocity more than 0. So this is gonna let the robot go straight with 0.2 meter per second the speed. So of course, as I told you that this is not the exact speed of the robot, but it gives some sense that it would go with around this speed because there is no feedback from the robot, so we cannot track the speed of the robot. Okay, so if we make it go faster, it just go faster and faster. So the maximum that I set for the ATCart is 2 meters per second, so you cannot go more than that. And also if I put some steering, put some angular velocity during it goes straight, so as you can guess, it will curve. So the left wheel velocity will be slower than the right wheel, so that means the angular velocity is like the right hand rules, so it's going to curve to the left side. If I make it more, then it will be more obvious. You can see that left wheel is really slow and right wheel is fast. So similarly, if I put this angular velocity on the minus side, so the right wheel going to be slow and the left wheel will be faster. Okay, so let's make it back to 0 again. And then also if we put it go back, the linear velocity will be negative. Then it's going to spin backward and the car will move backward. Yep, and we can also apply the steering or the angular velocity here. So what happens if your program stops sending the command velocity immediately? So you can see that the robot will stop immediately just to avoid some accident, because maybe the program is not perfect and you want to have some kind of safety that the robot will stop if something crashes. So you can notice that there is also the JMOAB wheels command topic, which we can send the percentage of the left and right wheel to the 100 numbers. For example, I'm going to SSH into the robot one more terminal, and then Jetson. Okay, if the mode is not in auto, then it's not going to print the log. Then what I can do is I can put this command ROS topic pop and JMOAB wheels command with the data type of float 32 multi-array, like this. And this is what we need to put. So for example, if I want to have the left wheel only spin 30% and the right wheel stay 0, I can do something like this and just publish. And then if I switch to auto mode, then you could see that the left wheel only spin during the right wheel stop. So if I stop this, it will stop immediately. And then if I put like 0 and 50% here, and you can notice that this spins faster than before and on the right wheel. So we can do something like this. Let's put this is 70% and this is minus 20%. So left wheel will spin backward and right wheel will spin forward. Something like this. So you can see how cool is this when we develop the robot with this kind of tools. So you can focus much more on the application, because on the low level side, it's already have this package that serves you. And that is how you can send the ROS2 topic of the command velocity and the wheels command to the JMOAB ROS2 package. And next video, let's apply this ATCart basic and the JMOAB ROS2 to some real application, so you can see that how the robot development process will be done. And stay tuned. And hey guys, before you go, I would like to show you more fun things. So I'm going to ride on the robot, and then let me prove to you that that robot is really powerful, that it can handle human weight. So my weight is 65 kilograms. It's not that heavy, but of course some heavier guys, it can also handle that. Okay, let me show you that. So now I'm sitting on the robot and I'm going to control it by the transmitter. So I set it on the manual mode, and then I can control it. So this looks like the real wheelchair robot, but you can control it really freely. And that is really fun. So what do you think the best application for this robot should do? Please comment below and stay tuned.